So with factoring, you guys, the first thing that we always look for is, can we take out a G, C, F? I'm really going for fun fonts today, people. For example, let's say we had a little, 5x cubed minus 25. Does that have a greatest common factor that I could factor out? Sure. What is it? 5. And what's left? Wow, when I take out a very ugly 5. What's left when I factor out a 5? Yeah. And can you double check that by just distributing that in? And you better get what you started with, right? We're good on GCF. Cool, cool, cool. Okay. Once you take out a factor, you're going to have either 2 terms, 3 terms, or 4 terms left. But I'm going to draw my 2 so cute. Look at this. I'm going to say, what? It's going to be like this. I think that's so cute. There's 2. My 3 is not as cute. My 4, it's getting worse. Things are getting worse, people. Oh, gosh. Okay. Oh, don't me. If there are 2 terms left. If there's 2 terms left, let me give you an example. Oh, man, that guy needs to go away. Okay. All right, 2 terms, such as, I'm actually going to have you leave some space right there. I want you to write 1 and then 2. So I want you to put your example right down here. 2 terms such as, what if I had x to the second minus 16? Yeah. If I had that, do you agree there's 2 terms here? Okay, in order to factor this, we have 2 requirements. 1, we have to be subtracting. We have to be subtracting in order to factor it. And then, does anyone remember how this would factor? Anyone remember? X? Yes. I do x plus 4 and then x minus 4 only because, Kate Mack, I like to say plinus plus minus. So that's the only reason I put the plus in front. But you could have totally done x minus 4, x plus 4. Okay, so you can do this when they're subtracting between the 2, and these are both perfect squares. Meaning I can take the square root of x squared to get x. I can take the square root of 16 to get 4. So we got 2 requirements. We got to be able to have, are they subtracting and are they both perfect squares? What's the matter, Danny? Did you have your hand up? No, okay. And if you can, that's when we can do this thing called, does anyone remember what this is called? Difference of, say that again? Yes, difference of squares. Okay, Gabe. So good. You can apply this, it's called difference of squares. And that makes sense. Difference means subtracting in math, right? Square meaning, are they perfect squares? And then I'm leaving this little box open. If both of those requirements are met, then your answer is going to look like this. Boop, boop. One's going to be plus, one's going to be minus. I like to say plinus. If we have 3 terms, and something with 3 terms could look like this. 1x squared plus x minus 12. Okay. Do you guys remember from Mr. Richards' class, how do we factor this? I wouldn't have remembered either, without polysmell. Does anyone remember how we factor those? Okay, I'm so glad you said that. She said add to 12 and multiply to 1, and it's flipped, Kate. And that's why I used toot, because I was you, Kate. And I was like, oh my gosh, do they multiply to be negative 12 or add to be negative 12? And I couldn't remember. So this is why I say toot. Here goes, people. I write a T over the middle term, an O over the last term, and then I write O-T. I'm making like a little chart over here on the right. And you're like, what are you saying? Did you even write toot? Well, check this out. When I write toot, my T is supposed to be like a plus sign. And then my O is like a multiplication dot. You feel me, people? And what that tells me is whatever the little multiplication dot is, Kate, that's what my numbers have to multiply to be. And so I'm going to put this number, negative 12, like in my little chart here. So I know I need 2 numbers that multiply to be negative 12. And then the T, it looks like an add sign. And it's whatever's in front of that number, whatever that coefficient is. And in this case, do you agree it's 1? So, Kate, I was the same way. I was like, oh my gosh, I can't remember if it's multiplied to be this number or add to be that number. I couldn't remember. So I came up with this toot, meaning what numbers multiply to be negative 12, multiplication dot looks like an O, and add to be 1. Negative 3 times 4, do you agree? Negative 3 times 4. Negative 3 times 4 is negative 12. Negative 3 plus 4 is 1. Agreed. And when you get those 2 numbers with toot, you get to jump straight to those parentheses. the whatever variable you had in front always leads the pack. We got x times x is x squared. And Worcester, you said -3 and 4. Since that 4 was positive, I'm going to put +4 and we're done. That's it. So I call this toot. And I know it's ridiculous, but I have found it is helpful. Now, the only time toot works is when this leading coefficient in front of the x squared is 1. So we often call these coefficients like a, b, and c. A here is 1, b here is 1, c is -12. So toot only works when a is 1. First question. First thing that we always do. Is there a GCF?
Yes.
Yeah, what's the GCF? Great. What's left when I take out that GCF? Girl, perfect. And I know she got it right because if I were to distribute that back, I would get what I started with. So I feel good about that live. Here's the deal then, you guys. What's left has 2 terms. With these 2 terms, could we potentially do difference of squares? Are we subtracting? Yes. Are they both perfect squares or both square rootable to get a whole number? I don't know what the square root of 3 is, do I? No. So this is as far as we can take it. We cannot do the difference of squares on those. Cool? On number 2, is there a GCF? The first thing we always do, is there a GCF? No? So we're going to jump to saying, hey, there's 2 terms. Are we subtracting between these 2 terms? Difference. Are they both square rootable or perfect squares? Yeah. So because it meets both those requirements, I'm going to go like this. Pew, 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 plus minus. That's what I like to do. Then what times itself gets me m squared? Or what's the square root of m squared? Am. Am times am is am squared. What's the square root of 16n squared? 4n, 4n. When we did this, these each have 2 terms. Could I do difference of squares on this set? Are we subtracting? No, so I can't do anything there. This one we are subtracting. Are these perfect squares? No, meaning I can't take the square root of m and get a whole number. So we're done. This one's done. Boop. Cool. What about number 4? Is there a GCF on number 4? We're taking out a 3, y'all. Take it out. Taking out a 3. What's left?
Wait, are we skipping?
What?
Yeah, we're skipping 3. We're going to come back to it.
X to the 20 minus 25.
Yes, sir. Can I do perfect squares on what's left in my parentheses? Perfect squares, difference of squares, my bad. Can I do difference of squares? Yes, there's 2 terms. We're subtracting. Are they both perfect squares? Yeah. So I'm going to bring down the 3. 3 is like your annoying little sister. 3 is just hanging out. I'm going to set up for difference of squares. What's the square root of x to the 4th? X squared. What's the square root of, what's the square root of 25? Beautiful. Question, could we do difference of squares on this part? We're not subtracting. What about this one? We're subtracting, but are these both perfect squares? No, we can't take it any further. We're going to look at problem 5. Since 5 is 1y squared, as soon as I see 1, I'm going to go to the middle term and I'm going to say T-O-O-T. I straight up write toot. What multiplies to be this last term, which was -84, and what adds to be this term, my t term, which is -5. This one's a toughie. I wouldn't give you one that would be this hard, honestly, because I would give you more common math facts. 12 and 7, yes. 12 and 7. As soon as you know, like, all right, 12 times 7 is 84, and 12 and 7 are 5 away from each other. I like that. What will be our negative? Which one is going to be negative? -12. Exactly. They have to add to be a -5. So we're going to jump straight here, and we're going to say y times y is my y squared. Danny said -12 and +7, and we're done. If Mr. Gabriel wrote y plus 7 and then y minus 12 and just switched the order, it makes no difference. If we were to distribute these through, you don't need to write this, we would get what we started with because -12y plus 7y is -5y. Sound good? Okay. Could I do toot on number 6? Yeah, 6, they didn't write it in descending order. We need to. So let's go rewrite this as 1r squared plus 18r plus 32. Because it's 1r squared, I'm going to go like this. T-O-O-T. Let's say you're like, dude, I do not need to toot. Great, don't do it. You don't need it. If you find that helpful, great, use it. But some people are like, no, I'm good. I feel fine with my factoring skills. Good for you. Me personally, I needed it. What multiplies to be 32 adds to be 18. 16 and 2. So Livy Lou, all you're going to do are 16 and 2. You didn't tell me any negatives, so I'm going to put plus signs in front of both of them, and you're done. Because 16 plus 2 is 18, and 16 times 2 is 32. On page 47, let's look at 9. Any GCF to get out? No GCF. Difference of squares a bowl? No. Are we subtracting? No. Therefore, we can't do anything. And when you can't do anything, we just say prime. Let's jump to 12. Is there a GCF on 12? Taking out a 2, what's left? 16 on the right, 16 q to the 4th, right? And then a p to the 4th? And minus that, love it. You guys, these have 2 terms. Can we do a difference of squares on those? Yes. So I'm going to get a pretty pink. I'm going to bring the annoying, I'm going to say little brother this time. Bring the annoying little brother down. Set up for difference of squares with a plus or a minus. Square root of p to the 4th. P squared. Square root of 16q to the 4th. What times itself gets me 16q to the 4th? Say it again, Livy. 4q to the 2nd. 4q to the 2nd. You guys, we can keep going. 2 is chilling. Why is this chilling? Because it's adding. This is a duo that has subtracting. Are these both perfect squares? Oh, snap. So everything else is going to come down. I'm bringing my 2. I'm bringing my p squared plus 4q squared. That's just chilling. But I am going to keep factoring this part, into a plus minus.
P plus 2q and p minus 2q.
So perfect. P, perfect problem for you. Square root of p squared, p times p gets me p squared. Square root of 4q squared is a 2q. 2q times 2q is 4q. Holy moly, 4q squared, my bad.
Are we going to be able to use a calculator on this part of the test?
Yeah, you guys, 14 is the one. 14 has a GCF. Let's take that GCF out. What is my GCF?
2.
A 2. What's left when I factor that out?
Negative 5m minus 24.
Minus 5m minus 24, but what would we start with?
M squared.
Yep, perfect. No worries. Okay. Because we have 1m squared, I can now T-O-O-T what's in my parentheses. I need numbers that multiply to be negative 24 and add to be negative 5.
Negative 8 and 3.
Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. The 2, my little Sib, he chilling. And then I'm just going to replace m minus 8 and m plus 3. Again, if my girl Allie Wall said 2 times m plus 3 and then put the m minus 8 at the end, who cares? It doesn't matter. We're good.